Hello! In this video, we'll explore the idea of integration by parts. Integration by parts is another integration technique for finding antiderivatives. Essentially, it reverses the product rule. There's no formal product rule for antiderivatives like there is for derivatives, but this integration by parts is essentially the reversal of the product rule. There's a formula associated with integration by parts which looks like this: the integral of u dv equals u times v minus the integral of v du. And we'll unpack this a little bit and see how to use this formula. In order to use integration by parts, we'll follow this procedure. First step is to look at our problem, and we want to split the integrand up into two pieces. So we take the given antiderivative, and we'll take the integrand and split it up into two pieces. One of them we call u, and whatever's left in the integrand we call dv. Second step is to find the derivative of u and the antiderivative of dv. So we find du by taking the derivative of u, and we find v by integrating dv. Once we've done that, we apply this integration by parts formula. Now, something to note with this formula: we use the letter u, but this is quite a different concept from how we do u substitution. So don't try to think of u as the same sort of an expression as what you get with u substitution. It's really a different sort of expression that we work with, and we work with it in a different way. Let's see an example of how to use integration by parts to solve an antiderivative problem. For this example, we're going to look at the integral of x times cosine of x dx. Integration by parts works well when we have integrands that involve a product. Generally speaking, integration by parts is a good technique to try if there's a product involved in the integrand. Here we have x times cosine of x. We're going to try integration by parts. First step, we pick part of this integrand to be u, and the rest is dv. For this one, we will choose u equal to x, and dv is everything that's left. Once we've picked part of the integral to be u, everything that's left has to be dv. So dv is cosine of x dx. Now, second step, we take the derivative of u, which is 1, and we solve this for du. Multiply both sides by dx, and we have du equals dx. In fact, we generally skip this intermediate step here. Next, we find v. v is the antiderivative of dv, so this is the antiderivative of cosine of x dx. The antiderivative of cosine is positive sine of x. And now we're ready for the last step to apply the formula. Remember, the formula for integration by parts is the integral of u dv equals u times v minus the integral of v du. So we plug everything in. We have u, that's x, times v, that's sine of x, minus the integral of v, sine of x, times du, which in this case is simply dx. Now we're ready to solve this final integral. We have x times the sine of x minus the antiderivative of sine. The antiderivative of sine is negative cosine of x, and then we add on a plus c. This is our answer. And that's how to use integration by parts.